All right, so we're going to step up our dimensional analysis by introducing combination unit conversions. We've already seen combination units in some way, shape, or form, but let me remind you what it might look like. A combination unit usually has this forward slash, and it has a unit in the numerator as well as a unit in the denominator. So the one thing we want to know is that we are never going to represent a combo unit with the forward slash in it in our dimensional analysis problems. We want to make these clean fractions. What I mean by a clean fraction is if I had 36 meters per second, I could represent it like this as a conversion factor or like this. Keep in mind the 36 must stay with the meter. The magnitude must stay with the unit it is next to, which is why I have my 36 meters either on the top or on the bottom. This is basically just a ratio. It's 36 meters for every second per second. Typically what I do is I take combo units and I write as ratio if it's built into a problem, just to make it a little bit clearer as to not to use a forward slash in my problems. This is just another example. If I have 722 miles per hour, I can separate my combo unit by keeping the 722 with the mile unit, and then the hour is the other side of my ratio. So this is how you do not want to represent your combo units, and this is how you do want to represent your combo units. So when it comes to Sig Figs in your answer, remember that Sig Figs are related to values that have a certain level of uncertainty, like measurements. Remember that there are also numbers that are exact that do not require Sig Fig rules, but anytime you're presented with a problem that has multiple measurements, you are going to follow the multiplication and division rules in determining the number of Sig Figs in your answer. So I'll try to emphasize that more if we reach a problem that is related to that. Okay, so here is the first example. We're going to convert 0.083 kilometers per hour to meters per second. The idea behind converting a combo unit into a new combo unit is that you are going to convert your numerator to numerator and your denominator to denominator. Okay, so let me say that again. You're basically doing a conversion between your numerator to numerator and your denominator to denominator. So the first thing we want to do is we want to think about the relationship between kilometers and meters. At this point in this course, you should already know off the top of your head there are 1,000 meters in a kilometer. You should know that off the top of your head. However, if for some reason you don't know that, you can always refer to this conversion paper, not on a test or quiz, but at least through your homework. And here's your conversion of 1,000 meters is equal to 1 kilometer. It's okay if you flip-flop the ratios because they mean the same exact thing. The next thing we want to do is we want to find a conversion or think about the conversions between hours to seconds. So hours and seconds are related through time, and this is common knowledge. And I think that you shouldn't have to refer to your conversion sheet, but if for some reason you need to, here are your ratios from hours to minutes and minutes to seconds. So we know that there are 60 minutes in an hour and 60 seconds in 1 minute. Okay, so we have all the ratios we need for this problem, and if you're wondering about the green versus the blue, I wanted to show you the separation between the numerator conversions and the denominator conversions. And so you'll see that color-coded throughout so you can see where we're going with our dimensional analysis setup. So typically we've been starting with our given over 1, but in this case our given is a combo unit. So we're going to go ahead and write our given as a combo unit. I have 0.083 kilometers per hour. Here's our given. I'm going to start off by just focusing on the numerator. So right now, just mentally block out that denominator and let's focus on converting the numerator. The rules have not changed. If I have kilometers in the numerator, diagonal from that, I also need kilometers. So 1 kilometer goes in the bottom and 1,000 meters goes in the top. So when I cancel out my units diagonally, it leaves me with meters in the numerator, which is what I wanted in my final answer. Now I can focus on the denominator. I don't have to set up a completely different dimensional analysis problem. I strongly recommend that you solve this all in one problem. You could set it up separately, but it's better to just solve it all in one so you're not losing digits due to rounding. The rules haven't changed. The only difference is that instead of the diagonal cancellation this way, we're going to have a diagonal cancellation this way. So if 1 hour is in the denominator, I'm going to have 1 hour in the numerator. The other side of my ratio is 60 seconds, so that goes in the denominator. Remember, everything above and below is a ratio, and hours cancels out with hours. So far, so good. Minutes need to cancel out with minutes. Here's where I'm pulling that minute conversion, and 60 seconds goes in the denominator. So just to double check, my units cancel out diagonally, leaving me with seconds in the denominator, and I have meters over seconds, which is what I wanted, so that's good. Now for the numerical answer, I'm typing in my calculator 0.083 times 1,000 divided by 60 divided by 60. Here's my numerical answer. I want a unit of meters per second. And to correctly represent this using the correct number of sig figs, I look at my given, and my given has 2 sig figs. Remember, leading zeros are not significant. And I count 1, 2, 3 stays of 3, and my final answer is 0.023 meters per second. Now, a few things I want to say about this. I did not take these ratios into consideration for significant figures because these are exact conversions, the exact value conversions, and they're not taken into account for significant figures. Another thing I want to say is if you haven't heard this in another video, if you've always wondered why we're able to cancel out units this way, it's because if you think about the math behind it, when you have kilometers divided by kilometers, that is equal to 1. And anything times 1 is itself. So that's why we just cancel them out. Units cancel out the same way numbers do.